All right. Use a random integer from 0 through 5 to represent the number of boys in a family of 5 children. So, we're trying to find why the following simulations fails to model the real situation properly. So, what's the issue with this one?
I mean, like, you can't do that.
Well,
Why?
because it doesn't tell you how many parents? I don't know. Wait, I guess it's
Are all possible outcomes equally likely?
Equally likely.
No. Okay.
Because, like, I'm not gonna try this, but
So,
I don't know, maybe some people.
every time a family has a baby, right, there are only 2 options.
Yeah.
Okay?
Right.
Boy or girl. Okay? So, the odds of you getting 5 boys or 5 girls is not the same as you getting 3 boys and 2 girls, or 1 girl and 4 boys, or something like that.
Makes a lot of sense.
So, not all outcomes are equally likely. For example, all boys is less likely than 3 boys and 2 girls. Okay, they're also using random integers from 0 through 5, which is not, doesn't logically make sense. There are not 5 options. There are 2 options.
Yeah.
There are 5 times that basically you need to run it to see, okay? So the first one, is it a boy or a girl? Second one, boy or a girl. Okay, if you were going to use a random number table, we would probably need to use 0 through 4 to be boy and 5 through 9 to be girl. Or we need to use the random integer on your calculator, which is what we're going to do. And we're going to say that boys are 1s and girls are 0s. And so then using the random integer function on your calculator that we looked at yesterday, it's going to be the random integer of 0, 1, and we need 5 of them to come up. So when you hit enter every time, it's going to produce 5 numbers, 0 through, 0 or 1. It's going to produce 5 0 or 1s. Okay? And so we are going to run 4 trials, I guess, 3 or 4 trials, and see what happens on each one. So remember, you go to math, and then the prob, and then the random integer. Oh, well, we're actually gonna do it this way. We're gonna run 20 trials since we can do it quickly. Every time, write down on your paper how many boys you got. So like on the first one for me, I got 1 1 0 1 0. So I got 3 boys. So write down the number of boys until you get to 20 trials. So I got 3 on the first one, and you can do however many you got. On the second one, I got 1, and so on and so forth. So run 20 trials, and then we're going to use that to explain what the percentages are. Interesting. After you're done with that, total up how many times you had like 0, 1, 2, 3, 4, and 5 boys. And make sure it adds up to 20 when you are done. This is kind of just bonus. This isn't actually what this question's asking for, but
Right.
just getting used to it. So once you do that, we're going to take the total number that you got for each like quantity. So like 1 out of 20, and we're going to get that percentage, okay, of how many times we got 0 boys, how many times we got 1, how many times we got 2, and so on and so forth, till we get all the percentages. And basically that's just going to show us what the most likely amount of boys you are going to get, and then we'll compare what each other got. So just take however many you got out of 20. Did anybody get no boys besides me? How many times did you, like that you got 0? Like I was all zeros that came up. How many times did you get it? Once. So both of you got it once. Did y'all get no boys at all?
Nope.
Okay.
No boys.
Did you get all boys at any point? Anyone?
Yes.
How many times?
Once.
Just once. Okay. Then what was your most common? How many boys was your most common? What was your highest percentage?
32.
Peyton's was 2.
2 boys.
Nathan was 2. Josh was 3.
1.
1?
1.
Wow. How many times did it happen?
It happened 8 times.
Wow. I don't think I've ever had that one come up that many times. It's interesting. Obviously mine was 3.
My 2 was 10.
My 3 was 8.
So my thing seems to be
My
like
one
happy.
was 5.
Wow.
But yeah,
My 1 was also 5.
I had it.
My 2 was 5.
3 was the highest, but then I had it
My 2
evenly
was 7,
distributed
my
between
3
the 1,
was
2, and
5.
4. I had 4
My
for
3
each
was
of
2.
those.
My 2 was 10.
But yeah, so all of what we just did was really bonus, but
Extra credit.
we were just supposed to explain what the problem was with the simulation they gave us, but we took it a little farther and actually, just so you could see it, it's always good to see extra examples of, one, how should we have done it instead? And so that's why we did that. Because sometimes in answering what the problem is, it's better to show what they should have done. It's like those describe incorrect problems that were in the Algebra 2 book all the time. All right, the next one, simulate a baseball player's performance at bat by letting 0 be an out, 1 be a single, 2 be a double, 3 be a triple, and 4 be a home run. What's the problem with this one?
Those don't have the same chance
Yep. Not all equally likely. I know, I'm sure that was mind-blowing. Okay, before we can do this, we would need to know what the probability of each outcome would be, like, in general, like with the game pieces. We need to know how many how
Yeah.
often that typically happens. Because obviously,
We didn't really get
I
it.
think probably out of everything, just statistically, the hardest thing to get in baseball is a triple.
Yeah.
I can get plenty of outs. Like, I can get out. Like, I can get them.
So I have a
No,
question.
like wins.
Yes.
What would be a scenario when all outcomes are equally likely?
Like free throws, because you can make or miss. Or if this had been simulated differently. Part of this was, like, there's always a 50-50 chance of getting a boy or a girl. But the problem with why this wasn't equally likely is because they were using the numbers 0 through 5 to represent, but there's only 2 options. That was what wasn't equally likely. If they had used 0 through 4 and then 5 through 9, so like 0 through 4 for boys, 5 through 9 for girls, then it would have been equally likely because there's still a 50-50 chance.
Yeah. Okay.
But it's a lot in how they've simulated it, basically, to know that. You need to know the probability of each outcome before simulating.
Like, it's implied that the probability of if it's a boy or a girl is 50%. Because,
Yeah.
but it's not implied the probability of the baseball player.
Well, yeah, and also with this one, the number of boys in a family of 5 children, that's not, again, equally likely either because
Yeah.
there's a whole different probability every time. There's a 50% chance every time for there to be. Now, statistically, is that really the likelihood? I don't know. But in theory, that should be the likelihood.
It's not like if you get a
Because
first
obviously
one,
you have, families that have, 5 kids and they're all girls. Or vice versa. Like, that happens. So,
Yeah.
oh look, we're getting ready to do a free throw problem.
Why does Kobe
I didn't even know it was next. I knew it was in, like, this unit, but I
I
didn't know it was
wish I
next.
had an 80% free throw success rate.
real?
I don't know what my free throw success rate would be, but I'm sure it would be like really low.
Mine's
Maybe
probably
like
like
single digits.
10%.
All right. Suppose a basketball player has an 80% free throw success rate. Dear goodness, okay. How many shots might she be able to make in a row without missing? So this problem is going to kind of run us through several of those 7 steps, some of them kind of combined to do this. So we're going to describe how we are going to simulate a component. And so a component is the most basic event that we're simulating. Okay, so we're going to basically taking one shot. We're going to use random integers. From 0 through 9. And I'm going to do this one with the random number table, so you're going to need that. Where 0 through 7, because that's going to be 80%, is basically a success, a good shot. And 8 and 9, because that would be the other 20%, is a miss. So, describe how you will simulate a trial. So, basically, we are going to shoot shot after shot. until she misses. So specifically what I'm going to do is I'm going to look at a random number table. And when I actually go to run the simulation, I will specify which rows I'm using for that. But look at a random number table, find a series of numbers, until we find an 8 or a 9. So it's basically I'm counting make, miss. Okay, when she gets to the miss, we stop. We're looking for how many makes before there was a miss. So describe the response variable. Any idea what the response variable would be for this?
The miss.
The other.
The make.
Number of shots without missing. So we're going to count the number of shots without missing. So run a simulation with 20 trials. What is your conclusion? So I'm going to use, just to do something a little different, rows 20 through 40 on your random number table. Okay? You can pick whichever rows you want. If you want to do it different from what I'm going to do, or if we want to do it all together, that's fine too. But I'm going to mark down for each row. I'm going to just set up each row 20, 21, 22, and so on and so forth. And then I'll put, that way as I go, I can just write down beside it how many makes there were. And there's no rhyme or reason to why I picked 20 through 40. It just did. You could have picked 17 through 37 if you were just so inclined.
We're putting how many were made, right?
Yeah. So basically, to show you, so on row 20, there's a make, then there's a miss right away. So there was one make, so you would put 1. In row 21, there was a make, then there was a miss, so you'd put 1, and so on and so forth. So go through and look at that and tally those up with whatever rows you've chosen.
If there's not a miss, we just count how many makes were in that.
We just keep going on.
You go all the way across the row until there's a miss. And if for some reason there's not, then we would need to go to another row. Which I guess could theoretically happen, but not super likely. And if the initial shot is a miss, then you just obviously put a 0. Alright, you get that? Alright, so now what you're going to do is take up all of the total number of shots that we had, okay? And we are going to find the average number of shots before a miss. So you just add them all up, divide by 20. You know, I know y'all know how to take an average, so.
I'm not sure if you noticed, but we did 21 trials with 2340.
That is true.
Then divide by 21.
Even more accurate.
So as a conclusion, did everybody do these rows or did y'all pick other rows?
I did.
Okay. So basically, she might shoot about 3.6, but we know that we should probably say 4 because, or, well, realistically we need to round down on this, but 4 shots before she misses on average. Basically is how we would write a conclusion for that. So, what do you think we should do if her success rate was only 72%? How would we change what we did?
We would have to change which numbers were associated with makes and misses.
So like rather than 0 through 9, we would go from like 0, 0 to like 9, 9.
Yeah. Basically, we're going to have to do, well, you have 2 options. If you're doing it on the random number table, like we just did, we would have to do 0, 0 through 9, 9. Okay? So, 0 through 99. Where 0, 0 through 71, okay, because 0, 0 is accounted for as a number as well, would be your success, and then 72 through 99, so 72 through 99 would be a miss at that point. Okay. Now, if you do it on your calculator can read numbers 1 through 100, and so you could just do 1 through 72 and 73 to 100, or you can do 0 to 71 and 72 to 99. But your calculator has the ability of producing the random numbers for you. So it would be a little different. So a couple options. So basically we would do the number 0, 0 through 99 on the table, where 0, 0 through 71 is a good shot, and 72 through 99 is a miss. If we did it on the calculator, then we could do 0 through 71, or sorry, 0 through 99, where 0 through 71 is a good shot, and 72 through 99 is a miss. And then we would basically just do the same thing over again. Now, I'm going to show you on the table what this would look like and how we would do it with the 2 numbers on there. So basically, I'm going to go back to, well, I'll just do row 1 because you can see it. Oh, actually, that's a bad example. I'll actually get far enough with row 2. So with row 2, my first two numbers together are 71, which is a make. Then the next two numbers are 62, which is a make. Then I have a 2 by itself, so what I do is I jump to the next number, so that would be 23, that's a make. The next 2 is 59, that's a make. 40 is a make. And then the next two numbers are 81, which is a miss, and so I had 5 makes and then a miss if it was done that way. Okay. I think once you get to numbers like that, it's easier to use the calculator. So, and realistically, as long as you know how to use a random number table, if it was given to you and forced that you do it, that's the biggest thing, because you can use your calculator and just get random integers that way. Okay. Next page. A large manufacturer of orange drink knows that historically 10% of its bottles come off the production line underfilled, 15% are overfilled, and the remaining bottles are filled correctly. Conduct a simulation to estimate how many orange drink bottles the company needs to pull off the production line to be sure of ending up with 10 correctly filled bottles. So, describe how you would use a calculator to conduct this simulation. So I would always start off by writing your percentages down first in numerical order. So we've got 10% are underfilled, 15% are overfilled, and that means that 75% are correct. And the reason I do this is because if I have increments of 10s, I can use 0 through 9, right? But because I have basically 5s involved, I'm going to have to use double-digit numbers. Now, with the calculator, I can do it a little differently, but let's say I was doing the random number table, I would need double-digit numbers from the beginning. So, basically, what I'm going to say is that 0 through 9 is going to represent underfilled, okay, because that's 10%. And I'm doing this because all you would have to do to use a random number table is change it from 0 through 9, from 0, 0 to 0, 9 to use that. For the 15% overfilled, it's going to be 10 through 24. And then for the correctly filled, it's going to be 25 through 99. Okay, and again, because it's on the calculator, I could have done 1 through 100 because your calculator can produce the numbers specifically. But this way, if you change the random number table, that only thing you have to change is 0, 0 through 0, 9. And you can do that on your calculator too. Like your calculator can still produce a 2-digit number if you would prefer it that way. But so basically, what I'm going to do, now this kind of ends up, it's kind of going to be C, but we're going to do it up here with our calculator, and then C is actually using a table. So we have the random integers, function on your calculator from 0 through 99, taken one at a time. So every time I hit enter, okay, I'm looking to see if it's correct or if it's basically out of the range. And so I'm going until I get 10 in the range, because I have to have 10 filled bottle, like 10 that are filled correctly. So I'm just going to do this one time through. So if you don't get a number 25 through 99, it's out of range. So I would just do some tally here, out of range and in range, and just keep the tally that way.
Should we go until we get 10 that are in range?
Yes. And so then just mark, so if you get it from 25 through 99, mark it as in range. Otherwise, mark it as out of range. And then total up how many total bottles you had to pull until you got 10 that were correctly filled. So for me, it took 13. I had 3 that were not in range and 10 that were. Yours was also 13.
Took me 12.
Oh, Peyton got 12. Josh,
14.
14. Nathan, 15. Ooh. Nathan's took the longest. All right, so that's what we would do on the calculator. Now, that's one trial. Okay? We needed 10 correctly filled bottles for one trial. So, between all of us, we ran 5 trials, basically. Okay? But you would have to run that at least 2 more times, like if you were doing it by yourself compared to what you did to get that. But obviously, realistically, we want 20, but that can take a little bit to do. So then that's if we were to do it on the calculator. If we were to use a random number table to conduct the simulation, basically I'm just going to modify what we wrote up top to be used for the random number table. And so we need 2-digit numbers this time because they all need to be the same length. So for under, it's going to be 00 to 09. For over, it's going to be 10 through 24. And for correct, it's going to be 25 through 99. So we are going to look at the random number table. Do I have one that's already written? All right, I'm going to use rows 13, 14, and 15. I would say at least do one of the rows with me, and then if you want to do the other 2 by yourself to try it, you can. But those are the rows I'm going to pick. So 13, 14.
Do the rows have to be in order?
No, it can be completely random. I'm just looking at where I don't have anything marked on mine already. Because I'm going to actually have to physically mark this. So basically what I would do when I do these problems, I'm going to slide this over out of the way for a second, is I would take your random number table that I gave you, so you can see this one's already marked up from something else. I was grabbing this one. So I'm going to use rows 13, 14, and 15. And again, don't forget, always specify to me what rows you're using if you use a random number table on a quiz or a test, so that I know if I need to go back and check something. I mean, not that I really should need to, because it's kind of just take it for what it is, but I can go back and check and make sure you really know what you were doing. So I'm going to underline in this blue, green, turquoisey color if it is correctly filled, and in purple if it is under or overfilled. Okay? So if it's anything 25 to 99, I'm going to do this turquoise color. Anything else is going to be purple. So row 13, 89, that was correctly filled. 05 was not correctly filled. 94. Okay, so the 9 and 4 go together. That was correctly filled. 35 was correctly filled. 28 is correctly filled. 10 is not. So hold on, how many am I at? 1, 2, 3, 4. So I have 4 so far. 54 is correct. 74 is correct. 01 is not. 15 is not. 82 is. 23 is not. 48 is. I need to go back and see how many I'm at because I need 10. 1, 2, 3, 4, 6, 7, 8. So I have 8 so far that are correctly filled. 69 is correct. So that's 9. And then one more. 02 is not. 04 is not. 12 is not. 18 is not. 38 is. And so finally I am done. Okay, so I have now 10 correctly filled bottles, but I need to go back and see how many that actually ended up being that it took to get me there. Zoom in maybe so y'all can kind of see it. Not that it's not blurry, but so in total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It took 19 bottles on that one. Okay. Took 19 bottles to get, whoa, it's really zoomed in. 19 before 10 correctly filled. So I'm going to go through and I'm going to mark 14 and 15, but try at least one of those on your own. Like, try to go through it on your own and see if you can mark it correctly and see if you should get the same thing I end up getting.
So we can choose different rows if we want to.
Yeah, you can choose whatever row you want. If you're wanting to check it with me, though, I'm doing 14 and 15. And don't be like, well, I'm going to go down the row and see which one, looks like it's going to get there the fastest. Like do it as purely random. So obviously we only did 3 trials again with that because it's quite tedious to do this problem by hand. But what we would do is we would take and we would, for our conclusion aspect of this problem, we are going to add up the numbers that you got, so whatever rows you picked, and then divide by 3. So 19 plus 11 plus 14 for me, divided by 3. So I would say something in the conclusion like the maximum number of bottles it took was 19. Now, if yours was more, obviously say that. And the minimum number was 11 for me. But what is it possible that the minimum could have been?
10.
Yep, but could be 10. We'd always want to point that out. And then ultimately I would want to say on average, now my average ended up being 14.6 repeating, but I need to round up because I can't pull 2/3 of a bottle. So on average it took 15 bottles to get 10 correctly filled. And so because you can, 1, your calculator can produce different numbers if you did on your calculator. 2, because on the random number table you could choose any rows unless I specifically specify you need to use rows 13, 14, and 15. I'm not going back to necessarily see that your averages are right. I'm making sure that your wording is correct and that you've listed everything in the conclusion that you need. Okay, so I'm looking for the min value, what the possible minimum value was, the maximum value, and then on average how many it took based on what you got. Gracious. So, all that being said, time-wise, we need to stop. We'll have a 1-and-1 free throw problem tomorrow, and then we'll have a multiple choice quiz problem where we will specifically go through all 7 steps of what we would need to do. We've just been kind of lumping things together in the problems that we've done so far. So what specifically it looks like to do all the steps individually.